Hello. So, right now we've got pretty much a triangle. That's nice. What if we want to make a bunch of triangles? The philosophy of Vulkan is to sort of do as much upfront as possible, and so we don't really have the facility to throw a whole bunch of data at the GPU, but we do have push constants, and what push constants let us do is send a very small amount of data. In this case, we can send enough to send over one model matrix and put this triangle at a bunch of different positions. That's what we'll do here. So we'll have a number of steps to go through. First thing is I'm going to head to the vertex shader, and for these positions I'm going to shrink them down. I'm going to make them 10 times smaller so I can fit more triangles on the screen. Then I want to declare a push constant. Now, push constants have a slightly different syntax. It's not a standard GLSL feature, so there is some documentation online. We can just do a Google search for KHRGSL, and there's a documentation here. We can look through it. It's not quite as easy to read as the WGSL documentation I was looking at in the past, but we can search it. So I'm looking for push constants, and here it turns out they give us an example of how to use it. They give us an example of how to use it. So we have layout and then push constant, and then uniform, and then these other names are up to us. Okay, cool. So let's implement that. So we'll go layout, push constant, uniform. I can call this anything I want. I'm going to call it constants. And inside we're going to have a model matrix. And optional name at the end, I'm going to call this object data. Okay, so now we can use it. We can say the position is we grab object data, grab the model matrix from it, and multiply that in. Cool. So we can just go to the shader folder and compile that. Okay, that looks like it's worked. Now, the next thing we'll do is we'll go to the pipeline file and we will declare that we are using, what am I thinking? Declare that we're using the push constant. So we'll go down and the push constant is declared in the pipeline layout because we need to set this up so the pipeline knows what to expect. There are more sophisticated ways to calculate the size, but we have 4x4 elements and each of them is a float, so it has 4 bytes. Okay, so now we can say, alrighty, we're using one push constant range. We're not declaring any descriptor sets yet, so we won't worry about that. There we go. Set up the push constant ranges. There's just one of them, and it's described by the push constant info. Okay, good. So now I just realized, just thought to myself, we're going to be making matrices, and we're also going to need vectors to describe the positions for the matrices. So what we can do is just go to, where are we? Config. And I'm going to import to classes, modules. Okay, so peer constructs matrices, NumPy describes vectors. Okay, so now let's create a simple class which will describe a bunch of positions for the triangles. Might be a little overkill to make a class for this right now, but in future we'll be extending it. Okay, so nothing too exciting. We're just creating a grid of positions that'll cover the screen. Okay, so now we can go to our app and give the app a scene. And down here in the main loop, we will pass that scene over to the engine to deal with. Okay, now we'll go to the engine. What do we have here? Render, okay. Take the scene in there and pretty much just pass it along to the record draw commands and use it at that point. And then we'll go up to record draw commands, take the scene, and okay, so again, look through it here. We have begin render pass, bind pipeline, and then draw over here. And this is the part that we want to repeat. So we'll turn this into a loop. Now what I need to do, there's sort of two tasks. The first task is to make a transform matrix from the position, and then to sort of get that over to the GPU. Okay, cool. So what we need to do is we need to go Vulkan command push constants. We specify a few things. We specify the command buffer that we're working with, the pipeline layout that we're working with, the stage that we're pushing this onto, the offset, the size of data that we're pushing. Again, we could just write 64, but I like that. Okay. And then the values. Now this is where it gets tricky. So we'd be tempted to say, well, typically we just do something like that. We just wrap it up in a list and we'd say, okay, under the hood, the API will handle that. Now let's try that. Spoiler alert, it won't work. Okay, so it says here, oh, scene has no attribute triangle positions. Have I... What have I done? This isn't the error I was talking about. Oh, yeah. Got it. Got it. Self-scene. It's good to run the code every now and then to catch those errors. Okay, so this is really weird. It's sort of under the hood. Vulkan is doing this... never mind. Under the hood, Vulkan's doing this sort of pointer casting things, and it just can't handle it. So another thing we could do is we could just go this. I can go through many permutations of things that I tried. Array item of unknown size void, so that's weird. What we need to do is this is sort of going to take a void pointer that points to the beginning of a block of data. Okay. And let's do this. Let's do this another way. Let's go FFI address of that. I mean, that's right. This is a block of data. That's the beginning of it. That doesn't work either. Expected to see data object got numpy nd array. So let's go to the actual sort of solution here. So I'm going to make a variable called object data. And the way this works is we go ffi cast. We want to cast this to a float pointer because, you know, it's the address of a bunch of float data. And then we put in ffi from buffer. This is just one of those things. This is one of those, like, takes a lot of sniffing around to find that hack. Okay, so we're putting that in, fingers crossed. And now it's working. But you may notice that there's an issue, specifically the frame rate. The frame rate has dipped. It was at about 3000 before, now it's at about 300. So that's not great, which there's several reasons that this could be happening. One of the reasons I suspect is that Python is slow, especially loops, because I'm just doing this in a regular Python loop. So anyway, long story short, there are better ways to send over a bunch of positions. We'll be looking at those in future. But basically what we would do is set up a whole buffer of positions for every single triangle, send that over all at once, and the rendering will be faster. But I was surprised because in C++ it's not this slow. Okay, so there we have that. And yeah, hope you enjoyed this little installment, and there will be more in future. Okay, see you. Bye.